What do you see here? No, that's not some blurry dot. That's a real treasure for the international scientific community. The James Webb Space Telescope is already proven it's worth every cent spent on it. It's taken more sensational photos than all other telescopes did before, even if we take all of their progress achieved over the entire era of space exploration. This dot is the first direct image of exoplanet HIP 65426b. James Webb has made a major breakthrough in astronomy because we've never actually seen exoplanets before and could trace them only by indirect signs, such as changes in the brightness of their stars, for example. And now we can stare directly at them. Although besides the beautiful photos of planets, star formation, the pillars of creation, and a spiral phantom galaxy, the telescope detected something that completely shatters all our established ideas about space. The number of discoveries is so huge that it seems that quite soon we'll have to throw away all astronomy books published before 2022. So, which of them is most likely to turn your world upside down? Scientists used to be excited about the functionality of Hubble, but James Webb is 100 times more powerful than its predecessor. This is hardly a surprise since its development started in 1996 and the telescope's design has been repeatedly improved. Right now, it has only begun its interstellar journey. James Webb was launched in 2021 and its mission is expected to continue for another 20 years. Thanks to its top-notch equipment and ability to make observations in the infrared spectrum, Webb can detect feeble signals and radiation, meaning that even the most distant space objects won't go unnoticed. However, it turns out astronomers weren't prepared to face most of them because the telescope showed the scientific society something that doesn't fit into our traditional worldview. Scientists thought it took around 10 billion years for any galaxy to form. For instance, our Milky Way needed 13.6 billion years, and it's considered quite mature. But in 2022, the James Webb Space Telescope destroyed the hypothesis about galaxy evolution once and for all because of these pictures. During the first months of the telescope's deployment, it spotted the oldest corners of the universe and photographed 6 objects that looked incredibly luminous and were glowing red. Everything indicates that we see something massive captured here. These dots turned out to be galaxies. Measuring the amount of light and the wavelength let astronomers assume how far each of them is situated and how many stars they may contain. The problem is that when we look at anything from cosmic distances, we see the past of this object. That's because light travels at a finite speed and needs a certain amount of time to reach our telescope. For example, if a star is 100 light-years away from Earth, it'll take its light a century to get to our planet. Consequently, even though we're looking at this star in the present, we see it the way it was 100 years ago. With this in mind, scientists determined when exactly the discovered galaxies emitted light in this range. It turned out that the Webb recorded them the way they were almost immediately after their birth, which was 700 million years after the Big Bang. Therefore, these galaxies are a bit younger than the Milky Way, approximately 13 billion years old. What's surprising is that usually, just like young stars, young galaxies radiate blue light. Well, in the images taken by the James Webb, it's clearly visible that these formations glow bright red. Astronomers found the news alarming because after decades of space exploration, they've come to the following conclusion. The richer and brighter the light is, the more stars the galaxy producing it has. If there are more than just a few, it means the system has existed for a pretty long time. One of the discovered galaxies contains a colossal number of stars whose mass is 10 billion times greater than that of our Sun. And yet, according to scientific estimations, 700 million years after the Big Bang, the universe just didn't have enough energy to create such enormous galaxies. Naturally, scientists rushed to try and figure out if the telescope could be so drastically wrong, but it wasn't. So it looks like, to explain these 6 sensational findings, we have to question the models of fundamental cosmology and revise our understanding of how galaxies were formed and how events following the Big Bang unfolded. Although now it's unclear if there was any Big Bang at all. Today, even small kids can tell you the universe started from a tiny speck and a giant explosion. As an adult, you can be more specific and reply that, according to scientists, the universe began as a dot of infinite density and temperature. Then there was the Big Bang. In the first minutes after it, the dot originally became plasma but cooled down over time. Thus, the first elementary particles, photons and neutrons, began to form. They later combined into atoms, which in turn became building blocks of stars, planets, and vast galaxies. Starting from the Bang itself and up to this day, our universe has been expanding like a firework, exploding in different shapes that spread in all directions at around the same speed to around the same distance away. The only difference is that, on a cosmic scale, it looks like a slow-motion scene where editors overused the effect. But what made us believe that this was the case? In the early 20th century, astronomers found that distant galaxies scatter in various directions. The blast could well have triggered this movement. Of course, it's not a confirmed hypothesis, but rather an assumption that, back in the day, seemed the most believable. That's because all other speculations about the birth of our universe couldn't simultaneously explain all the confusing phenomena in outer space. Like, for example, its homogeneity, or cosmic microwave background that's considered a leftover from the Big Bang. Not bad. It turns out that this theory has clarified 3 inexplicable things in one go. And now we have only a few thousand mysteries left to solve. Sounds great. Let's make it generally accepted. The fact that this model of creation has long lost its credibility became obvious to Nobel Prize winner Dr. John Mather. Can you guess why? Because he's the senior project scientist for the James Webb Space Telescope. That means this man can study space a bit closer and see the true essence of things. After working with the state-of-the-art telescope for some time, John said that astronomers had coined the worst possible term to describe the events that took place in the universe's first instance. When we hear the word bang, we indeed imagine something like a firework or firecracker exploding at a particular time and place with a center. The universe, according to Mather, doesn't have a center. Therefore, the Big Bang happened, so to say, everywhere at once, no matter how hard it is to grasp. The telescope clearly shows us that lots of galaxies in the universe move, but they drift away from each other rather than from some imaginary central point. Besides, over the last decade of space observations, many astronomers noticed another detail that questions the Big Bang model. If the universe became homogeneous as a result of the Bang, it should have produced about the same amount of matter and antimatter. But relevant calculations showed that the world was apparently focused on only one thing. There's so little antimatter in the universe that its amount is no more than 1/quadrillionth of the total amount of regular matter. This asymmetry can be explained by another bold theory stating that the Big Bang did happen, but in very unusual circumstances. It could have been triggered by a collision between the universe and an anti-universe. Followers of this theory believe that our universe moves forward in time, while its mirror opposite, filled with antimatter, moves backward. At some point, they crashed into each other, and this caused the formation of stars, planets, and galaxies. As you can see, all attempts to find reasonable facts to back up the long-held beliefs about the origins of our universe, including the Big Bang, look pretty crazy. However, alternative versions don't sound very convincing either. For example, before scientists came up with the Big Bang Theory, the majority of them used to agree that the universe has always been there and looked exactly the way we see it right now. Assuming that space is static sounds both vague and very philosophical, but even this argument seemed to please most experts. Of course, until they discovered the universe is expanding, which proves that it's dynamic in nature. A few fresh thoughts came from Russian scientists from the Perimeter Institute for Theoretical Physics. They think that our universe sprang from a star's collapse in another four-dimensional universe. According to them, everything around us is just a holographic mirage or some sort of a membrane floating through an even more dimensional universe. And now it suddenly seems more like a fantasy screenplay than a scientific fact. In the meantime, Roger Penrose, a physicist at Oxford University, claims that the Big Bang really happened, but it wasn't the beginning of the universe. It was just a transition stage. According to his theory, space goes through cycles of expansion and contraction. During the contraction cycles, black holes reduce universal chaos by absorbing energy, matter, and eventually each other. Then, the universe self-destructs by shrinking into one dot, and a new Big Bang takes place, followed by expansion. The list of wild theories goes on and on. The most ironic thing is that the James Webb can't bring peace to the world of constantly arguing scientists, as the telescope can offer a glimpse into history only after the Big Bang. The brightest minds are yet to design a more powerful telescope that'll let us see the universe the moment it was born and help us either prove or disprove the Big Bang Theory. That's why the only thing cosmologists can do is suggest different hypotheses relying on already known properties of the universe they have no doubts about. But as you might imagine, some of these properties shouldn't have been taken at face value. Scientists keep trying to derive theories of the world's evolution that would work fine, even considering that the universe is homogeneous and looks the same in all directions. This means that if you analyze a large-scale picture of space, one region will be barely different from any other wherever you look. However, some of the recently discovered space phenomena debunk this, and it wasn't even the revolutionary James Webb Space Telescope that helped scientists notice the oversight. In 2004, a NASA satellite created a map of the cosmic microwave background. That's the remnant of the radiation emitted 380,000 years after the Big Bang. Even though early astronomical research suggested that the temperature of this light had to be roughly the same everywhere, the map revealed several anomalies. The first one is called the axis of evil. It's a long stretch with above-average temperatures. Moreover, there are clear cold and hot spots located on opposite sides of the axis. But away from these sections, the temperature becomes uniform again. What's funny, the former US President George Bush used the term axis of evil to describe authoritarian regimes that sponsor terrorism. Despite this, scientists picked such a loud and infamous name not because this space phenomenon is dangerous. They did it because its discovery enraged all the cosmologists in the world. The point is that the temperature deviation had no logical explanation in the context of the Big Bang model that everyone had grown to like so much. But as I've already told you, the axis of evil isn't the only anomaly in the cosmic microwave background. The second one is this circular region. This time, scientists were less dramatic and called it the CMB cold spot. It was discovered in 2004 by NASA's Wilkinson Microwave Anisotropy Probe, and then Space Observatory Planck confirmed the information. The region got its name because the temperature of the cosmic microwave background there is much lower than in the other parts of the sky. More precisely, that area is 70 microkelvins colder than the surrounding space, where the temperature reaches 2.7 kelvins. On top of that, this place has almost no stars and galaxies. That's why astronomers consider it a dead zone, although this definition may also be far from the truth. Almost instantly after the anomaly was detected, astronomers in charge of decoding data sent back by the Voyager probes discovered something unbelievable. The spacecraft picked up a signal coming from somewhere near the CMB cold spot. At first, scientists were sure there had to be a mistake and hurried to double-check the archival materials. As a result, they realized that the same thing had already happened before, and several years after the Cosmic Background Explorer had been launched, NASA began receiving the first signals coming from this region. At that time, the agency chose to ignore them. But what is the true nature of this mysterious cold spot? Worldwide famous physicist Stephen Hawking thought it could be some sort of an imprint of other worlds. Hawking saw a universe as a quantum system that's not homogeneous in its structure after all, and exists in multiple states at the same time. As for the cold spot, he thought it could transmit signals sent from neighboring universes. Despite our conclusion that this area looks dead most of the time, a million different space systems might exist on its reverse side. It's pity Hawking never had a chance to prove this. At the turn of the 21st century, researchers were introduced to yet another mind-boggling theory. It stated that the cold spot is something like a mirror that will never show you reflections, as if someone was consciously trying to disguise this zone and didn't expect us to notice it. The signals coming from that place aren't messages sent by extraterrestrials to people in hopes of having a friendly chat. They are rather polite requests to quit prying. These mysterious signals keep reaching Earth and remain undeciphered to the present day. We can neither prove nor disprove the existence of other universes and their inhabitants. And you know what? Since the axis of evil in the cold spot cannot be fully explained, some scientists dismiss them as statistical errors too. These doubting experts are waiting for more modern spacecraft to find more accurate data so that they can officially confirm their suspicions. But I'm afraid repeated tests may frustrate astronomers even more, just like it usually happens. The disappointment might be even deeper than it was when they realized the colossal mistake made while studying galaxy formation. Do you know what the main ingredient of any galaxy is? Scientists will give you a clue. It's called dark matter. In 1965, American astronomer Vera Rubin began working in the Department of Terrestrial Magnetism of the Carnegie Institution for Science, where a young staff member named Kent Ford had just constructed an image tube spectrograph, an instrument that allows experts to observe very distant space objects. Rubin and Ford wanted to determine the orbital speeds of stars at different distances from the galactic center. They started their research with the Milky Way's closest neighbor, the Andromeda Galaxy. Considering Newton's law of gravity, scientists assumed that stars located farther away from the center should move slower in such galaxies. Surprisingly enough, they understood it wasn't the case. More distant stars moved just as fast as those closer to the center. By the end of the 1970s, Rubin and her colleagues investigated dozens of similar galaxies and only validated their conclusions. This meant that besides the mass of gas and dust visible through telescopes, there was some other force keeping stars within galaxies. What could be acting as this space glue? That was when Vera Rubin came up with the idea that there might be a certain invisible substance, dark matter. But in those days, her reasoning faced a cool reception. The scientific world respected Newton's laws and wasn't going to let anyone defy them. Her discovery gained recognition only much later. Nowadays, astronomers believe that dark matter makes up about 85% of all the matter in our universe. Quite recently, though, scientists discovered objects that cancel everything I've just said. In November of 2019, the Hubble Space Telescope took a picture of a galaxy called NGC 1052DF2 that contains almost no dark matter. The galaxy itself is one big anomaly. Its density is so low that you can look straight through it. And it's not the only oddity that baffles cosmologists. With the help of the 500-meter aperture spherical telescope, Chinese astronomers found a dwarf galaxy situated 94 million light-years away from us. And it also runs counter to scientists' expectations. This galaxy is called FAST J0139 plus 4328, and it hardly emits any light. That's because it harbors an extreme amount of dark matter, 98% of its total mass. While NGC 1052DF2 has too little dark matter, in this galaxy, there's an apparent overabundance of it. As you can see, scientists haven't had great success in understanding the nature and properties of this substance, and they still have a long way to go. Oh, right, I forgot to tell you the most crucial detail. They have no factual proof that dark matter exists at all. Can you believe this? Researchers rack their brains over untypical proportions of something that may be nothing more than a figment of their imagination. We can only wonder how many discouraging revelations James Webb will drop in the upcoming years, and how shocked scientists may get as a result, and especially how shocked we may get. Let's be honest, regular people tend to blindly trust everything that starts with the phrase, "Scientists have found." Sooner or later, everything we've known might turn out to be an estimation error. I think the James Webb and other spacecraft that'll be designed in the future will be practically almighty in outer space. They may capture evidence proving that the universe is self-destructing, or bring home another message from aliens. Or maybe they'll discover that extraterrestrial civilizations use similar telescopes. Since those creatures live so far away, their devices can only show them Earth during the dinosaur era. If so, extraterrestrials may not be interested in our planet because all they see are diplodocuses and tyrannosauruses able to generate only primitive thoughts, if any at all. What do you think? Share your thoughts in the comments.